It's been an extraordinary year for the Rosetta mission. Since landing on Comet 67P Churyumov-Gerasimenko, the combination of continual data from the orbiter plus several days' data from the Philae lander has provided a comprehensive picture of a remnant from our solar system billions of years old. Recent images of the comet have revealed unusual terraces or strata, rather like the layers of an onion, as well as pits containing walls up to 400 metres high. These layers help scientists determine that the comet was formed by a collision between two comets, resulting in its distinctive rubber duck shape. The comet has no magnetic field, but Rosetta has identified a number of gases from the nucleus, including water vapour, carbon dioxide, hydrogen sulfide, and even argon, the first time it's been detected on a comet. These gases were traced by Rosetta's Rosina instrument, and its laboratory is based here at the University of Bern in Switzerland. The latest discovery is familiar on Earth, but not on a comet.
The biggest surprise so far is certainly molecular oxygen, because that was not expected at all. And this tells us a lot about where this material comes from, where it was formed. It correlates very well with water, and I think, I'm not sure, but I think it shows you that the water was formed in the molecular cloud and not in our solar system. It was already existing when it entered the solar system.
The water coming from the comet was also shown to have a different isotopic ratio to that on Earth. The unusual shape of the comet, with one lobe much larger than the other, means that as it spins through space, parts of the comet are often in and out of shadow. The Virtus instrument has revealed how water has been transported from within the comet to its surface via sublimation, where water changes from ice to a gas without going through a liquid phase.
We measure the abundance of ice and the temperature in different points, getting closer to the shadows. And you see an anti-correlation. When you have the maximum abundance of ice, you have the minimum temperature. As soon as the temperature increases, the ice diminishes, because it's sublimating away.
These images show the changes on the surface from red, with no water ice, to blue, where ice has appeared, all within several hours. The European Rosetta mission covers many facilities across numerous countries. At ESA's European Space Astronomy Centre in Madrid, you can find Rosetta mission manager Patrick Martin.
The mission extension will last until end of September next year, and the idea is to spiral down the orbiter, Rosetta, towards the comet slowly, diminishing its altitude, and then settle the spacecraft on the surface, hoping to be able to control it as long as possible.
When Rosetta descends towards the comet, it will enjoy an equally close-up view to its Philae lander 1 year ago. By then, the mission will have used 21 different instruments to study a comet at all stages of its activity. From approaching the Sun, to being at its closest distance or perihelion, to moving away from the Sun back towards the cold outer reaches of our solar system. It will provide insight into our planet's own formation by giving us the most detailed knowledge yet of a comet.